Okay, let's go ahead and go over this. All right, so probably a sample of 30 workers has an average of more than 43 hours. There is a mean in this. There's a sample size. I have an n. Do you guys see my n? What's my n?
30.
30. When you have an n, that means it's probably central limit theorem, right? Because all of a sudden I have a sample, the probability that sample has an average of more than 43. So now I'm not going to use 4 for my standard deviation. Instead, my standard deviation is going to be sigma x bar, which is going to be the old sigma over square root of n. So 4 over square root of 30. What is that? What do you guys get for that?
0.7.
0.73? Give me one more. 730?
Yeah.
Okay, great. So then we do the same stuff. I find a z-score, right? It's 43 minus 40 over 0.730, and you guys got 4.11?
1. Well, yeah.
Great. So then again, you're going to draw your little picture. Notch here, 4.11, greater than that, normal CDF, 4.11, comma, I don't know, 99, sure. And what do you guys get?
0.000.
Someone give me the, did anybody get what'd you get? You got some,
Oh, I got 1.97 e to negative 5.
Yeah.
e negative 5. So again, anytime you have a probability larger than 1, right, it should be less than 1, right? Anytime it's 1 or larger, then you should be looking for that e negative something.
Yeah.
Absolutely, because you're never going to have probability more than 100%. So look for that e negative something, and that tells you, oh, e negative 5. The easiest way one of my students told me to do this was put 5 decimal places in front. 1, 2, 3, 4, 5 zeros. Sorry, 1, 2, 3, 4, 5 zeros. 1, 9, 7, and put the decimal place after the first one, after the first 0, because that moves it over. 1, 2, 3, 4, 5. Otherwise, you got to count and do 1, 2, 3, 4, 5, and if it goes beyond 4, then I can always make a mistake. So I just put it 5 zeros, put the decimal place after the first one, because this always is going to have one number in front of the decimal place, so that makes that easy. Good. So the camera can see that.
Would you want to surround it to the
Yeah, I can.
2? Or would you like us to keep it at 197?
3 sig figs is good.
Okay.
I think 3 sig figs in general is good.
Okay.
Yeah.
But
So don't give me 1 decimal place, but if you give me 2, I'm probably gonna be okay with that. If you give me 3, I'm gonna be okay with that.
okay, so
Yeah.
you can do that 197, but would we chastise if we did round it up to that?
Oh, this one right here?
Yeah.
Well, yeah, I need to have at least something. If you put 0.00002, I'd be okay with
Okay.
that because it's so small.
Yeah.
Yeah, but generally speaking, I like to have 3 sig figs.
Okay.
Yeah, but in that case, because it's so small, that's fine. Okay, so do you guys see the difference? If you're talking about just 1, 22, almost 23%. If you're talking about a sample of 30, then all of a sudden, getting an average of of 43 is a lot more. It's a lot harder. And maybe these numbers are unreasonable. Maybe I should have made this a standard deviation of 8, right? And made this 46 hours. But then you'd still get 0.75 there. And then if I did it here, 46 hours, then we'd have 46 over this, which is still going to be, this would be 8. So then this would be 1.7, 1.46. That's still going to be really small. It's still going to be 3 something, almost 3, 6, over 3, and it's still going to give you. It's still going to be 0. Yeah, let's make it like 3, something over 3, and so you're still going to get roughly 0, right? Almost 0, because sure, one guy can make could work 46 hours a week, but to take a sample of 30 people and have their average all be 46 hours or more a week, that's kind of hard, right? Because you'll have a bunch of deadbeats who only work 30 hours a week, right, or whatever. So they kind of all average out. Or, hardworking students who have to go to school also, things like that. Yeah. Okay. No, I don't work as much anymore. I'm going to be perfectly happy to work, to retire when I retire. Oh, I can handle that. Just teach once in a while. Okay. Though if I just told a friend, because she was like, oh, let's do the lottery together. I'm like, yeah, okay, but I don't really care if I win because I would still teach. I love teaching. It's a lot of fun. So, oh well. All right.
Isn't that a statistical almost impossibility to win?
It's really rare to win. Yeah, it's really really hard. But yeah, totally. Okay, what else do you guys want? Someone give me a problem they want to go over or look at or question about something else. Does the central limit theorem make sense to folks?
Yes.
And the Q is again, look for a sample size. Sample of, if you have an N, then that means a really good chance that, I shouldn't say it's just an N, because it has to be a mean with an N. Do you guys understand what I'm saying? Because if there's an N, it could be binomials have a P in an N, any probability in an N, but they won't have a mean with an N. So these will have a mean with an N. Okay. Someone give me another problem.
Are we going to be going over Chebyshev's theorem in the test as well?
Chebyshev's theorem, yeah, it might come up. I can see that. Just the basic application of it, and I would probably prompt you by saying use Chebyshev's because, otherwise you might assume it's normal and try to use empirical rule, right? It gets a little too close. So, but yeah, what does Chebyshev say? Do you guys remember what Chebyshev says?
It's 1 minus 1 over k to k squared.
Right. I probably would not even push you that hard. I'd probably say just the basic application of Chebyshev's, which is just looking at, and I'd probably narrow it down to just looking at 2 standard deviations and 3 standard deviations. So I'm going to keep it cleaner than that even. Chebyshev's. Is it Chevs with a C?
Yeah.
Chebyshev's. Says that at least what percent?
75% within 2 standard deviations.
At least 75% of data lies within 2 standard deviations of the mean. And that's at least. Please note the at least. Often more. Almost always more. But the very, very worst you can do is 75%. Right? Very often you'll get more like 95%. But at least 75%. And then, what was the other thing that I covered? At least what?
89%.
Yep, 89% or like 88.9%, but yeah, if you round to the whole percent, 89%.
Lie within 3 standard deviations of mean.
Yep, within 3 standard deviations of the mean. At least. Again, very often more like 99%, but at least 89%. So I might prompt you for that, and I might expect you to be able to find, if the mean is the mean is 600 and standard deviation is 42, or we'll make it 40. We'll keep it cleaner, right? Then you'd say that at least 75% lies within what, and at least 89% lies within what? So tell me that.
75% lies between 520 and 680.
Everybody find those. Yep. We'll fill these out. Lies between blank and blank. So everybody find those 15 more. You guys all found them already?
easy
And
call.
sometimes we'll find it, helpful to like draw a little spot where their mean is, right? And my mean is 600, and then kind of jump over, in different directions. So this would be 640 would be 1 standard deviation, then 680, and then 720. And over here, what backwards? 560, 520, 480. So what did you say, Jay? Between
520,
uh-huh.
680.
Right. So from here, your mean to this way, 520, to that way, 580. Within 2 means 2 this way and 2 that way. Okay, at least 89% lies between, Andre?
480 and 720.
480 and 720. Great. Now, I'm going to do a little switch on you guys. You guys okay? You guys good with this? Move it, switch something else? Okay, empirical rule. Different. The empirical rule is sort of a simple rule. It's for normal distributions only. So empirical rule only applies to normal distributions, but if your data is approximately normal distributed, then you can do better than Chebyshev. What does the empirical rule say? Anybody?
68% lies within 1 standard deviation.
Yep. About 68% of data. So now it's not at least, it's about. It means right around lies within 1 standard deviation. What else does it say? Someone else give me another one?
About 95% is within 2 standard deviations.
95% lies within 2 standard deviations. And this one, and then there's one more, which is?
99.7% falls within 3 standard deviations.
Yep, about 99.7% falls within or lies within 3 standard deviations. Good. So that would mean about 68 would fall between what and what in this problem, in this situation?
560 and 640.
560 and 640. About 95% lies between what and what?
520 and
520 and
680.
680, good. And about 99.7 lies
480 and
720 and 720, perfect. Good. So if I say empirical rule, I might give you this, or I might expect you to find this. I might say about what percent lies, between 520 and 680. So then you'd make your little thing and say, oh, 520 and 680, that's 2 this way, 2 that way, so that's 95%. Right, you can work it that way. Good. Okay, another question, next question.
You done this again? I did it Monday.
Definitions,
Oh.
things that we're going to, obviously, we're going to know what is
I can
Z
go
score
with like
is.
an
Is there
hour.
anything else besides that that we need to?
No,
The 20,
And I
you
feel
do need
like
to know what a z-score
22
is,
problems,
absolutely.
right?
But otherwise, I'm not going to ask you to
22
find anything
problems?
else. I'm lazy about that.
24.
But there were some that skip.
Fifth one?
Number 5?
We don't have to do, I think it
Yeah.
was,
That's true.
Okay.
1, 2. Yeah, only 2.
okay.
So you're right,
So
22
here's
problems.
number 5 on your study guide. And it says, here's a frequency distribution, 27 tides, find the mean. Do not use lists. So here's our rise, and here's our frequency. 30, 35, 40, 45, 50, 55. There's 6 of those, 2 of those, 4 of those, 8 of those, 5 of those, and 2 of those. Okay, so the first one, find the mean. So I have 6 of these, right? Everyone follow me? So it means I could just do this. 30, 30, 30, 30, 30, 30. And then I have 2 35s. I have 4 40s. I've got 8 45s. That's a lot. And 5 50s. And 2 55s. Now, I could just average these, right? Add them all up, divide by how many there are. That's my way of finding the mean. But there's a shortcut you can use, since some of them are the same number. Instead of adding 30 6 times, I can just take 30 times 6, 180, and add that to everything, right? So this is just shortcutting adding these guys. And I can shortcut adding these two by saying 35 times 2, that's 70. 40 times 4, that's 160. 45 times 8, that's 90, 90, 180, 360.
Yeah.
And then 250, and then 110. And then add these guys. So this just makes it a little bit quicker rather than adding all of these to just multiply and add these. But if you want, you can totally just add those instead. That's fine. It's either way. Either multiplying these across and adding these is the same as adding those. You can do either one. You'll still get the same result. 5, 5, 3, 2, 3, 4, 5. 1,030. Good? So this is just a shortcut for adding these all up. How do you find the mean? Add them all up and you divide by how many there are. How many of them are there? Are there only 6 days? Yeah, there's 27 of them. Do you see what I'm saying? There's 27 of them. This here is just a shortcut for adding them. There's still 6 of those, 2 of those, 4 of those, 8 of those, 5 of those, and 2 of those. This is how many days there are. So you have to add these up and find the mean by saying the mean then is going to be,
I think it's 1130.
oh, is it 1130? Sorry. The other way you can do it, the other way that will help you remember is maybe think of these by labels. So this is rise and this is frequency, or this is days. Is this days? Okay, so one thing is you always divide by your frequency. That's the first thing. But say there's something different, like say rise and day. So this would be rise times day. You guys kind of follow what I'm saying? You did rise. So this is really 1130 rise times day. And do I want the average rise or the average number of days? I want the average rise. So I'm going to divide by the number of days so that these guys cancel out. And I'm just left with rise. So that's another way of thinking about it, especially with the GPA problems. People get confused about which one to divide by. You want the average GPA. So you have your grade points times your credits. You need to divide by your credits to be left with your grade points. Do you guys want to go over one of those, or do you guys want to?
Isn't that
Yeah, do you want to go over that one, or do you guys want to go over something else, like what some of the, you guys feel really good about the normal stuff, is that the deal, because we've gone over it most recently?
I feel bad about everything, but I didn't think so.
All right, so, we could do GPA, what are the other things people want to go over? Yeah,
Just real quick, when you were dividing 1,130 divided by 27, the number that I got was 4185. What was, is that the
4185?
Yeah, 4185.
4185.
That's what else got, that seems good.
No, is that the standard deviation or?
That's the mean.
Mean.
Oh, the mean, the standard deviation, you put this into list 1, your frequency in list 2, and you do the, again, you do the 1 bar stats, L1 comma L2. And that's the easiest way to find standard deviation, yeah.
I did the same thing, I got two different answers.
Did you do L1 comma L2?
Uh,
Oh, this one is 1130. That's 1030.
Never mind.
Sorry. I'm sorry. So yeah, whenever you use the calculator, make sure you really show your work, because at least you'll get partial credit. But 2, double check what you put in, because really it's really easy to mistype a key and get the wrong answer because you just mistyped something. Okay, what problem do you guys want to work on next? Okay, anybody else have one that you would rather do instead? No? 15. Oh yeah, producer. Okay, that's good. Producer plans an outdoor regatta for May 3rd. The cost of the regatta is $8,000. He plans to make $15,000 profit if all goes well. So profit means what you get after you pay all your expenses. Do you know what I'm saying? Profit is gross is what you take in total. So he would take in a total of $23,000 gross, which means you take in your gross, you subtract off what your expenses are, the $8,000, you're left with profit, $15,000 profit. Do you know what I'm saying? So he's up 15 grand at the end if all goes well. If it rains, the regatta gets canceled and he loses 8 grand. AGS is going through that right now. They have this conference going on. If all goes well and people come to the conference this weekend, then they will break even or make a very small profit. But if things go poorly, because a lot of colleges are saying we are not letting our students and our advisors go to your conference and travel, then they're going to lose possibly $100,000 because the hotel is not letting them out of it, because you have these costs, right? So, yeah, sucks, totally sucks. However, right, so here, if it rains, the regatta will have to be canceled. The probability of rain is 0.3, 30%. Find the producer's expected profit. So, we have 2 outcomes, right? What are they? Rain and no rain, yeah?
Yes.
Rain, no rain. Okay, good. Now, what does that mean? That's not our real x, though, because our real x is money or numbers. So what does this mean numerically if it rains?
Negative.
Negative what?
8,000.
8,000. I lose $8,000. What happens if there's no rain?
15,000.
I make $15,000, positive $15,000. And then, what's the probability of x? 0.3 is rain, and of no rain is 0.7. So again, expected value. Is this of the 4 distributions? Is this the binomial, the normal, the uniform, or the probability distribution table?
The discrete
Probability distribution table.
distribution.
Because am I doing now? If I was doing a regatta, it's either rain or no rain. But now I'm doing regatta, over and over again. I'm only doing it once. Do you see what I'm saying?
Yeah.
Yeah. Yeah. Now that'd be interesting to say. That'd be a great question to say. Well, what's the probability that he has exactly 5 regattas out of 7 possible days? That'd be a different thing. Yeah. But yes, so here, because yes, it is a yes or no, but I'm not doing it over and over again. I'm only doing 1 regatta once. So here, it's going to be that that frequency distribution table, how do we find the mean and standard deviation, or how do we find the mean of that? Anybody?
Sum of the x times
Yeah.
the probabilities.
Sum of the x times their probabilities. So I need to find every x value multiplied by its probability. Do that.